All right, welcome back, everybody. Happy Thursday. What an incredible month it's been trying to adjust to middle school. So I'm very proud of the progress everybody has made. I really appreciate all your hard work. And of course, all your family's hard work too. Okay, so today we're going to take a little bit of a turn in our lesson, in our normal lessons, and talk about area of a parallelogram. And then we're going to connect that to what that has to do with decimals. Okay, so make sure you write down the date. So today is the 23rd, 9/23/21. And our topic for today is going to be area of a parallelogram. Okay. So the question before we get started on finding the area, right, is what the heck is a parallelogram? So this might be a good time to pause the video real quick. Make sure you write down everything you need. And then copy down these three examples of the three different parallelograms that you've commonly seen before. And then come on back to the video, okay? All right, so welcome back. You probably already have written down all this information. And so what is a parallelogram? And what are the characteristics that we need to really understand, right? So a square is a very specific parallelogram, right? It means it's a parallelogram with all sides equal to each other. Now, I did my best trying to draw this, but these little lines indicate that each of these sides are equal length. Okay, so a square is a special kind of parallelogram. All right, and then we have the rectangle, right? So the rectangle is a parallelogram, and it has two sets of even or equal length sides, right? So this side is equal to this side, and this side is equal to this side, all right? And this is another parallelogram, right? So parallelograms don't always have to form 90-degree angles. They can look like this, kind of slanted, and this is a parallelogram, right? This is parallel forever, and this is parallel forever. So these two lines will never touch, and these two lines will never touch, in theory, right? All right, so these are parallelograms. So what are their characteristics, right? Here are the pieces you need to make sure you understand, right? Is what's the base and what's the height? Okay, so I'm going to use this red pen, okay, to write down H for height and B for the base, okay? So this in the square, this would be the height, and this bottom piece would be the base, okay? And similar in the rectangle, this would be the height of the rectangle. This would be the base of the rectangle, okay? And in a parallelogram, well, is this the height? Like, where do we find the height, right? And typically what you'll find is that it's drawn inside, okay? So in this type of parallelogram, this would be the height, and the bottom piece below here, the blue line, that would be the base, okay? So those are examples of parallelograms and what they mean, okay? And their characteristics, okay? So the next question we're gonna answer in this video is, well, of course, how do we find the area of these things? How do we do that? So let's write that question down. Okay, how do we find the area of a parallelogram? All right, hopefully I'm putting the L's in the right place. Sometimes I put the double L's in the wrong place, and I'm not sure if I did it now, but if I did, oh well. All right, so let's take a rectangle, right? Well, no, let's take the parallelogram because that one's more complex. So let's use this example, right? So I'm gonna draw my parallelogram as best I can. And if you're not good at drawing shapes, or you're not good at drawing at all, don't worry, all right? My first year teaching, when I had to teach geometry, well, my shapes were not very good, okay? All right, so let's say that this height is, let's say 2.5 centimeters, okay? And let's say that this length, this base, right, is, I don't know, let's say 10.2 centimeters. I'm just kind of making some stuff up, right? So how do we find the area of this thing? Okay, so make sure you've paused the video and you have copied down all the questions here and then the shapes here, okay? And let's talk about how we find the area of this thing. So let me zoom in on this. All right, so there's a formula. And the formula for area of a parallelogram says the area equals the base times the height, okay? So again, from our examples up here, what do you think the value of the base is? Because we're about to find the area of this thing, okay? So what is the value of the base in this one? So take a look at these examples, and what would it be? Would it be the 2.5 or the 10.2, okay? Now, if you guessed the 10.2, great job, that's correct, okay? So it's gonna be 10.2 times 2.5, okay? And we just set up our problem. Remember, for multiplication of decimals, we do not need to align the decimals, okay? We don't need to, but in this case, it's gonna be coincidental that they do, all right? So we're gonna take 10.2 times 2.5, and we start our multiplication algorithm, right? So we do 5 times 2, which is 10. I'm going to carry the 1, okay? And then we do 5 times 0, which is 0, plus 1 is 1. And then I do 5 times 1, which is 5, okay? I'm going to place a 0 for my placeholder, and then I continue on with the algorithm, okay? So I do 2 times 2, which is 4, 2 times 0, which is 0, and 2 times 1, which is 2. Okay, so our first set of values is 510, and the second set of values is 2040. Okay, let's double check our work though. Okay, 5 times 2 is 10, 0, carry the 1, 5 times 0 is 0, plus 1 is 1, 5 times 1 is 5, okay, 0, 2 times 2 is 4, 2 times 0 is 0, and 2 times 1 is 2. Okay, great. So double checked our work, looking good. Let's go ahead and add these things. Okay, so 0 plus 0 is 0. 1 plus 4 is 5. 5 plus 0 is 5. And we just bring down the 2 because there's nothing to add to that. So far we have 2,550, but that's not the area of this thing, right? We have to move the decimal over the number of times that we see a number to the right. So here's one number to the right of the decimal. Here's another number to the right of the decimal. So total is 2. So I'm going to move this decimal over 1, 2 times. And the area of this parallelogram is equal to 25.5 centimeters squared. Okay, so that's going to be important. All right, so if this was a multiple choice question, and you saw a number without this little squared, but the values were correct, you would still get that answer incorrect, okay? So make sure that you add this little squared here. And tomorrow during our lesson, we'll talk quickly about why we write it as a squared unit and not just as a linear unit, right? Just centimeters. So that is all for this lesson today, right? So this is how simple finding the area of a parallelogram can be. So hopefully this video is helpful. And then when we get done with this, hopefully we'll have some examples to practice today and put these notes to work. All right. So let me stop sharing here. And thank you all again for all your hard work and commitment to learning this year. And we will see you when we see you. Have a great day and take care.